ವಿನಾಯಕ ಇಲ್ಲೇ ವಿನಾಯಕ್ ಬರ್ತಾನೆ.
I request all the oral and poster presentation participants to kindly note the following instructions. For the oral presentation, please verify your assigned hall and session number for the presentation. Each presenter is allotted a total of 10 minutes, of which 8 minutes are for presentation and 2 minutes are for the discussion. Kindly keep track of time. A warning bell will ring at 7 minutes, followed by a final bell at 8 minutes. All participants are requested to strictly adhere to the schedule. And for the poster representation, the session will be held at the designated venue. Posters must be displayed only in the allotted spaces. A team of volunteers will be available to assist you. Further instructions regarding display and timing will be communicated subsequently. Thank you. Good morning. I request all the participants to gather inside the hall. The program will be held short while.
ಯಾರು ಕುಂತಿಲ್ಲಲ್ಲ. बोलो करो.
Good morning. I request all the dignitaries to have your seats on the dais.
Sir.
A very good morning to everyone.
I am Sushma.
I am Anjum, postgraduate student, Department of Physics, Karnatak University Dharwad. On behalf of the advisory and organizing committee, we extend a warm welcome to all the dignitaries, the invited speakers, invitees, faculty members, research scholars, the delegates, and the media representatives present here for the 2 days national conference on the 100 years of quantum physics, developments, and multidisciplinary applications in novel materials.
On this occasion, we have amidst us the chief guest, Professor K.C. Dappa, former Vice Chancellor, Bangalore University, guest of honor, Professor P.G. Mulimani, former Vice Chancellor, Gulbarga University and BLD University, keynote speaker, Professor S. Umapati, honorary Professor IISc Bengaluru, President Professor A.M. Khan, Honorable Vice Chancellor, Karnatak University Dharwad, President of the Organizing Committee, Professor Srimati Jayashree Jetonanagar, the convener, Professor R.F. Bajantri, the co-convener, Dr. A.S. Bernard, and the organizing secretary, Dr. Srimati Sukanya Patil.
This conference is organized under the PM Usha soft component activities in collaboration with the Karnataka State Higher Education Council under the sponsorship of Dr. Yamma Gorbal Foundation, the Karnatak University Physics Alumni Association and SPE Student Chapter, Karnatak University Dharwad. To commence the inaugural ceremony, I request the gathering to kindly stand for the Nadagite, the state anthem. Kindly be seated. May I now invite Professor R.F. Bajantri to welcome and brief the gathering about the conference. So please.
Respected Honorable Vice Chancellor, Professor A.M. Khan sir, distinguished keynote speaker, chief guest, guest of honor, eminent invited speakers, distinguished delegates, fellow faculty members, dear research scholars, MSc students, members of media, ladies and gentlemen. A very good morning to all of you. As the convener of this conference, it is a matter of honor and pride for me to welcome you to this 2 days national conference on 100 years of quantum physics, MCQP. So which is being organized by the Department of Physics, Karnatak University Dharwad under the soft component of PM Usha scheme. United Nations has proclaimed the year 2025 as International Year of Quantum Science and Technology, a global initiative recognized by UNESCO to commemorate the monumental scientific milestones. In this context, Government of India has launched the National Quantum Mission, aiming to seed, nurture and scale up scientific and industrial R&D activities and to create a vibrant and innovative ecosystem in quantum technology. In line with this, the Government of Karnataka also launched Karnataka Quantum Mission in the year 2025 with 1,000 crore. The initiative includes the development of quantum city and a quantum hardware park in Hesarghata and also in IISc quantum and also a 25 qubit system at IIT Dharwad. The idea is to mark the significance of quantum physics, its development and applications, and also it has revolutionized the human life, which will drive the next century of innovations. Quantum physics is not just an abstract science, it is the foundation of the modern digital age. From the MRI machines in our hospitals to GPS in our car. It is the bridge between the subatomic particle and a doctor's diagnosis. Whether it is quantum computing for fast drug discovery or novel materials for clean energy. Hence, the quantum mechanics has saved and connected the globe. In view of this, the Department of Physics is organizing the 2 days national level conference NCQP, which aims to bring the MA scientists, researchers, academicians and students together to exchange knowledge on the frontiers of quantum physics and emerging quantum technologies. In this conference, the deliberations will focus on the theoretical and experimental developments in quantum materials, novel functional materials, and multidisciplinary applications spanning physics, materials, electronics, and allied fields. On this occasion, we have with us Professor K. Siddhappa, former Vice Chancellor of Bangalore University and presently President of Karnataka Association for Advancement of Science and also Founder Director of Microtron Center, Bangalore University, as the Honorable Chief Guest of this conference to inaugurate this conference. On behalf of the Department of Physics, Karnataka University and Advisory and Organizing Committee, I wholeheartedly welcome Professor K. Siddhappa for graciously accepting our invitation and honoring this inaugural session with your esteemed presence and sparing your valuable time with us to inspire the young minds. As we gather to celebrate 100 years of quantum physics, it is with immense pleasure and deep sense of honor we extend our most cordial and respectful welcome to the visionary leader in the field of quantum science, Professor B.G. Mulimani sir, former Vice Chancellor Gulbarga University and BLD University, Vijapur, for his continuous guidance and support and also suggestions to organize this memorable event. I welcome you, sir. The culmination of a century of quantum discovery dedicated to pushing the boundaries in quantum technology, particularly in laser spectroscopy and artificial intelligence. It is profound privilege to welcome profound inspiration to the entire scientific community. As we gather to mark 100 years of quantum physics, it is with immense pleasure and deep sense of pride I welcome our Honorable Vice Chancellor Professor A.M. Khan sir, who is a distinguished researcher himself with pioneering work in biomedical imaging. Your presence today is highly inspiring. We honor you not only as the head of the university, but also as a distinguished professor of physics and electronics, whose heart beats for scientific discovery. Sir, welcome you, sir. It is a distinct privilege to welcome our esteemed invited speakers. We represent who represent the finest minds of global and national quantum leadership. Hence, I welcome distinguished invited speakers, Professor S.M. Shiv Prasad, visiting Professor IIT Dharwad and former Director Higher Education Academy. Welcome you, sir. And also I welcome Professor G.U. Kulkarni, former President of JNCAS. I welcome Professor B.A. Kagli, former Professor University and President, Karnataka Physics Association. Welcome you, sir. And also I welcome Professor A.R. Usha Devi, Professor at Bangalore University. Professor Prabhu from the Department of Physics, Indian Institute of Technology, Dharwad. I welcome you, sir. And I also welcome Professor V.M. Jali, former Professor, Physics Department, Gulbarga University. I welcome you, sir. And also I welcome N.S. Vidyadhi Raja, Professor at JNCSR, Bangalore, to this conference. So this conference is organized under the sponsorship of Pradhan Mantri Uchchatar Shiksha Abhiyan, PM Usha. We are grateful to Dr. M.R. Gorbal Foundation for their generous support for the academic activities of our department. So the M.R. Gorbal Foundation provided the conference kit to this conference. I welcome Sri S. Patil sir and others to this conference. And also I welcome Dr. M.R. Gorbal sir also. I also welcome the President of SPE Student Chapter, Professor S.R. Inamdar sir, for gracious presence and assistance. And also I welcome Physics Alumni Association for providing financial assistance. I also acknowledge the dedicated efforts of members of advisory and organizing committee and faculty, former faculty members, research scholars, student volunteers of this Department of Physics, whose collective commitment, dedicated efforts have made this conference possible, and I welcome you all. So we have received around 50 papers for presentations and around 200 registrations for participation in this conference. On behalf of the Department of Physics, Karnatak University Dharwad, I extend a warm welcome to all the delegates, participants and invitees to this conference. I also welcome the former faculty of the Department of Physics, Professor S.S. Kukati sir, L.R. Naik sir, Tonanavar sir. And I also welcome the President of this function, Professor J.J. Tonanavar madam. And also I welcome R.L. Patil sir, Kargupikar sir, and other distinguished Sankeshwar sir and other distinguished invitees to this conference. So I hope these 2 days will be academically enriching, intellectually stimulating and professionally rewarding. I encourage you to activate, participate in these deliberations, interact with experts and make the best use of this platform. I also welcome the syndicate members, academic council members, chairpersons of other departments, faculty members, PG students from other departments and also from the Department of Physics, research scholars, teaching assistants and faculty from KCD, JSS College, PC Javin College and other colleges and delegates from all the premier institutions, members of media and invitees. I welcome wholeheartedly to all of you to this conference. Thank you.
Thank you, sir. We shall now proceed with the introduction of the dignitaries. May I request Professor S.R. Inamdar to introduce and welcome Professor K. Siddhappa.
Very good morning to all of you. Respected and Honorable Vice Chancellor of Karnatak University, Professor A.M. Khan sir, distinguished Chief Guest, Professor K. Siddhappa, former Vice Chancellor of Bangalore University, Guests of Honor, Professor V.G. Mulimali, former Vice Chancellor of Gulbarga University and B.Ed. University, Bijapur, Professor S. Umapati, Honorary Professor at Indian Institute of Science, Bangalore, and a long-time academic associate of our department. Professor Jayashree Tonandar, Chairperson of the department. Professor R.F. Bajantri, convener of this two-day conference. Dr. Sukanya Patil, Secretary, and invited speakers, Professor Kagli, Dr. Prabhu, Professor S.M. Shiv Prasad and others, and our former teachers, Professor Kupkati, Professor Kargupikar, Professor R.L. Patil, and host of others, invitees, and our former colleagues, Professor Naik, Professor Sankeshwar, and invited speaker, one more invited speaker, Professor V.M. Jali, and invitees, and my dear students. A very good morning to all of you once again. It's a great pleasure and an honor for me to introduce the chief guest of today's function, Dr. K. Siddhappa, a renowned teacher, an outstanding scientist of international repute, a dynamic administrative leader, and former Vice Chancellor of Bangalore University. Dr. K. Siddhappa obtained his MSc degree in physics with distinction from the University of Mysore and completed his PhD in nuclear physics from Andhra University. He has served in the physics faculty in various positions at the University of Mysore and Bangalore University for nearly 33 years. While heading the physics department of Bangalore University, Dr. Siddhappa introduced a number of MSc students and very well. He carried out research in several key areas of nuclear and radiation physics. Director of Microtron facility with sophisticated infrastructure, he provided an opportunity to researchers to conduct research in interdisciplinary areas covering nuclear physics, radiation physics, material science, radiation biology, medical science, and nanoscience. The Microtron Center has nationwide users community, which includes Bhabha Atomic Research Center at Mumbai, ISRO and IISc at Bangalore, Rajaramana Center for Advanced Technology at Indore, IIT Madras, Chennai, VCC, Kolkata, SIT, Delhi, and a host of universities and electronics industries from Bangalore, Baroda, and among others. The Department of Atomic Energy has recognized Microtron Center as Center of Excellence, and the DST has recognized it as a national facility. The UGC has recognized this center as a center with potential for excellence. Dr. Siddhappa has guided a number of PhD students and published more than 300 research papers in national and international peer-reviewed journals of repute. He has participated in large number of international conferences. He has chaired several technical sessions and delivered many invited talks. He has visited the United States of America, Germany, Sweden, Finland, Italy, Yugoslavia, and other countries as visiting professor as well as a visiting scientist. Professor Siddhappa has served as member of governing councils and governing bodies of Nuclear Science Center, Delhi, Inter-University Center for Astronomy and Astrophysics, IUCA, Pune, IIM Bangalore, ISCC Bangalore, Kidwai Memorial Hospital in Bangalore, and many other national institutes and universities. He has served in important high-level committees of the UGC, DST, and Department of Atomic Energy. As Vice Chancellor of Bangalore University during 1999 to 2002, Professor Siddhappa introduced novel and innovative programs streamlined the administration and brought discipline in the university. These programs include introduction of compulsory computer science course with practical training to all the postgraduate students for the first time in the country. A biodiversity park was developed in the Jnana Bharati campus of Bangalore University by planting more than 5 lakh saplings of Western Ghats species of rich diversity. The biopark with rainwater harvesting and water bodies has a repository of biospecies with birds and animals. Under his able leadership, the Bangalore University got accreditation by the NAC with the highest 5-star rating. Professor Siddhappa is a recipient of a number of national and international awards ranging from the UGC National Associateship to the prestigious American Society Awards. He was awarded Sir M. Vishweshwaraya Senior Scientist Award from Karnataka State Council for Science and Technology in 2011 for his significant lifetime scientific contributions. Dr. Siddhappa, as Honorary Director of JSS Foundation for Science and Society and now as President of Karnataka Association for Advancement of Science, he is engaged in strengthening science education at all levels and in taking the fruits of science to the society. The Karnataka Association for the Advancement of Science, KAAS, is a non-profit organization established on July 7, 1981 in Bangalore. Professor Siddhappa has been associated with many academic activities of our department since a long time. And recently, he inaugurated one of the skill development and hands-on training program on foldscope microscope to our students, organized by our SPI Karnataka University Student Chapter in memory of the legendary teacher and educationist Professor M. I. Savanthi. And he was all appreciation for the activities of the SPI Student Chapter. On behalf of our department and the Karnataka University, and on behalf of all of you, I extend a warm welcome to Professor Siddhappa to this function. As a token of appreciation and affection, on behalf of all of you, I wish to present a memento to Professor Siddhappa. With these few words, I wish this conference a great success, and I thank the organizing committee and chairperson of this department for giving me an opportunity to say a few words about Professor Siddhappa. I also welcome Dr. Boli Shetty, director of this center, which I forgot. Thank you very much.
Thank you, sir. Now I invite Professor J.S. Devanmat to introduce and welcome the President of this function, Professor A.M. Khan, Honorable Vice Chancellor.
ಎಲ್ಲರಿಗೂ ಶುಭ ಮುಂಜಾನೆ ವಂದನೆಗಳು. Dignitaries on the dais and off the dais, it gives me immense pleasure to make a brief introduction of Professor A.M. Khan, the Honorable Vice Chancellor of Karnataka University. On the occasion of two-day national conference on the 100 years of quantum physics, development and multidisciplinary applications in novel materials, NCQP 2026. Professor Erani Ahmad Khan, born and brought up in Dharwad, and a multifaceted personality During his education, his teaching profession started in the Department of Electronics, Mangalore University, Mangalore. He was instrumental in overall growth of the department as a teacher and a researcher. Professor A.M. Khan has 31 years of teaching and research experience and 20 years of administrative experience. He had served as a registrar evaluation, director PB, director skill development, the member of the syndicate, academic council, the financial committee, and so on, prior to his appointment as a vice chancellor of our university on July 2025. Professor A.M. Khan has, to his credit, over 200 research publications, 10 research projects in collaboration with industry, institute, and medical universities. The two major research projects sponsored by DST and BRNS in the tune of 30 lakhs. Under his leadership, organized various state and national level conferences, seminars, workshops, symposia at the Mangalore University. Further, Professor A.M. Khan was instrumental in initiating Memorandum of Understanding with Indiana University, Pennsylvania, USA, and Cardiff Metropolitan University, Wales, UK. Professor A.M. Khan's research area include biomedical image processing, embedded system design, image data processing, algorithm development, IC fabrication technology, and computer networks. Under his able guideship, 11 students have completed their PhD, 1 student has completed MPhil, and 4 more still are pursuing his PhD. He is a member of Instrumentation Society of India, the Biomedical Electronics Society of India, Mangala Alumni Association, Mangalore University Teachers Association. Further, apart from having a member of selection by the academic bodies of various universities, he also held the responsible positions of the core committees of the government of Karnataka, like Karnataka Examination Authority for Software Development. So in essence, since A.M. Khan is a distinguished academician who transitioned from prominent role at a Mangalore University to lead another major university in the North Karnataka. So with these few remarks on Professor A.M. Khan, I wholeheartedly welcome our Honorable Vice Chancellor A.M. Khan, and as a token of love and affection, I offer a bouquet.
Thank you, sir. I now invite Professor Srimati Jayashree J. Tonanagar to introduce and welcome the guest of honor, Professor B.G. Mulina.
A very warm good morning to one and all. Today's chief guest, Professor A. Siddhappa, former Vice Chancellor, President of this occasion, Honorable Vice Chancellor Professor A.M. Khan, guest of honor Professor B.G. Mulina sir, Professor Umapati, the eminent scientist, esteemed invitees, resource persons, faculty members, former and present, research scholars, teaching assistants, and my dear students. I am very happy to introduce Professor B.G. Mulina sir to this audience, who was my teacher. Professor Mulina has an exceptional academic record, starting with his higher secondary certificate, where he secured the 5th rank in 1962. He graduated with first rank from Karnatak University Dharwad. He completed his MSc with a distinction from Karnataka University, and he earned his doctorate from McGill University in Montreal, Canada. Professor B.G. Mulimani's international visits and fellowships showcase a distinguished career with significant time spent in Canada, England, and Italy. He was a Canadian Commonwealth Fellow, during which time he pursued and earned his PhD at McGill University in Montreal, Canada. He was a visiting scientist in the same university from 1982 to 83. Sir was awarded a prestigious senior SERC, that is Science and Engineering Research Council Fellowship at the University of Warwick, England in 1989. He has also been a summer visitor at the renowned International Centre for ICTP in Trasti, Italy. He was a member for Vision Group for Science and Technology since 2008. He is an elected member for KSTA Government of Karnataka. In recognition of his contribution to the field of science and higher education, he is awarded with the Raja Ramanna Senior Scientist Award 2006 from Government of Karnataka. He is a recipient of the prestigious Sir M. Vishwesvaraya Lifetime Achievement Award, Government of Karnataka. He is a fellow of KSTA Bengaluru. He has served the Karnataka University at various capacities. He was a faculty member during 1968 to 2006. He was a chairperson of Department of Physics and Electronics for 2 terms. He has been a key contributor for the development of the department. He is an elected member of the syndicate of Karnataka University for 2 terms. He served on various committees at state and national levels, and he was associated with NAC activities. He served as the Vice Chancellor of Gulbarga University from 2006 to 2010, and later as a Vice Chancellor of BLDE University. He has been a driving force in uplifting research activities and PhD programs, encouraging quality research and collaborations, including an MOU between BLD University and Karnataka University for collaborative research. Sir is a prominent theoretical and experimental physicist specializing in condensed matter physics. His research extensively covers electronic transport and optical properties of low-dimensional semiconductor systems. His specific areas of research include semiconductor nanostructures, electron-phonon interactions, transport properties of modern materials, crystallography, and material science. Professor Mulimani sir has co-authored over 150 publications in national and international journals of repute, reflecting his significant impact on the field of academic physics. Presently, sir is involved in science education, science popularization, and service to society in the field of education. Thank you very much. Please join me in welcoming Professor B.G. Mulimani.
Thank you, Madam. I now request Professor J.R. Tonandavar to introduce and welcome the keynote speaker, Professor S. Umapati.
Good morning to all of you. I am indeed very happy to introduce Professor Shiva Umapati, whom I have known for a number of years, almost since 1992, and he is associated with our department as well as university at different levels, and we have had the benefit of his guidance and advice on important academic matters. He is a scientist of many achievements and honors. However, for want of time, I should restrict myself to a brief introduction of him. Dr. Shiva Umapati is an internationally recognized laser spectroscopist and also is a Raman spectroscopist, and is the honorary professor at the Indian Institute of Science, Bangalore, holding positions in the departments of inorganic and physical chemistry and also instrumentation and applied physics. His research interests include broadly
The applications of laser spectroscopy and technology development to physical, chemical sciences, materials, medicine, instrumentation development, microspectroscopy and ultrafast dynamics. Professor Umapati comes from Tanjavur, one of Tamil Nadu's historic cities, known for its culture of art and architecture, and as we all know from history, is a home to the Chola dynasty. After graduation from University of Madras, he earned a PhD in physical chemistry from the University of Otago, New Zealand. On a DST Serb fellowship, he did postdoctoral work at Rutherford Appleton Laboratory and the University of York, both in the United Kingdom. He then joined IAC in 90, where he served as professor in the Department of Instrumentation and Applied Physics, and also professor and chairman of the Department of Inorganic and Physical Chemistry. Professor Umapati's contributions include combining molecular dynamic simulations with different Raman spectroscopy techniques for the investigation of diverse systems, organic molecular species, quantum dots, diseases like flu, COVID-19, bacteria, and then so on. His group also utilizes other spectroscopic techniques like infrared and is involved in the examination of the molecular structure of cells and tissues. Using Raman spectroscopic techniques, he has developed a method to identify biomarkers in cells, which is estimated to assist in early cancer detection. All of this research has resulted in several peer-reviewed articles and large number of their citations. Professor Umapati is a fellow of the Royal Society of Chemistry, an elected fellow of the Indian National Science Academy, New Delhi, Indian Academy of Sciences, Bengaluru, and also National Academy of Science of India, Prayagraj. Among the several national and international prizes awarded to Professor Umapati, I single out 2004 Shanti Swarup Bhatnagar Prize for a significant contribution in the area of laser spectroscopy, in particular Raman spectroscopy, in the investigation of molecular dynamics. Professor Umapati also has been an academic administrator too. He served as the director of Indian Institute of Science Education and Research, popularly known as ISER, Bhopal, from 2018 to 23. Professor Umapati also has been Swarna Jayanti Fellow and is currently J.C. Bose National Fellow under the aegis of the Department of Science and Technology until 2027. He is visiting faculty and fellow to various institutions. For example, Kanagawa Academy of Science and Technology, Japan, University of Groningen, the Netherlands, Institute of Molecular Science, University of Tokyo, Japan, Imperial College of Science and Technology, and University of Nottingham, both again in the United Kingdom. Professor Umapati has pioneered new forms of spectroscopy, namely diffuse wave Raman spectroscopy and universal multi-angle Raman spectroscopy techniques, which allow for non-invasive detection of chemical information deeply buried under surfaces or in layered materials. He has a number of USA and Indian patents to his credit. What is more, Professor Umapati is a chairman, founding director and CEO of deep technology startup called Gyroid Photonics. Am I correct, Umapati? Which is a spin-off based on research and technology developed by the research group. This startup makes a portable Raman microspectrometer systems for rapid identification and classification of microscopic samples such as bacteria, blood, serum, nanoparticles, any material in low volume or quantity needing a microscope. With this brief introduction, please join me in welcoming Professor Chua Umapati.
Thank you, sir. Also, with the organizing team, welcome the President of the Organizing Committee, Professor Jayashree J. Navar, And I request Dr. Sukanya Patil to welcome her with a bouquet. Also, we welcome Professor R.F. Bajantri, the convener, and may I request Mr. Mohan to welcome him with a bouquet.
Thank you. We shall now proceed with the inauguration of the conference. May I request the dignitaries on the dais for the ceremonial lighting of the lamp.
This compendium of abstracts contains the work of invited speakers and also the research work of the delegates.
Thank you. We shall now proceed with the felicitation of the dignitaries, before which I request Professor J.R. Tonanavar to speak a few words about felicitation to Professor N. Umakant.
Most of the students here may not have seen Professor Umakant, N. Umakant. He was our teacher and also distinguished scientist in the Department of Physics. Today he is 93 years old, 93 plus, and is unable to come here because of his old age. Since this conference is about or to mark the 100 years of quantum physics, Professor N. Umakant has contributed to the foundations of quantum physics, quantum mechanics. And therefore, the advisory committee felt that it is also an occasion to acknowledge his contribution to the same field, foundations of quantum mechanics. Very briefly, Professor N. Umakant joined Bhabha Atomic Research Center in the year 1956. Then it was called the Atomic Energy Establishment when Dr. Bhabha was there. And from there he moved to our department, joined as a faculty member, and then carried out research work broadly in three areas: nuclear physics, molecular physics, and then the foundations of quantum mechanics, with which he was very passionately associated, because he believed that there is something wrong with the foundations of quantum physics, and therefore he had to contribute something to that. What he called it as representation or represental approach to quantum mechanics. And therefore, apart from his other research interests, Professor Umakant also published papers, despite the fact that many reviewers did not accept his interpretation. Finally, he decided to publish a book that's called The Principles of Quantum Mechanics, in the bracket, in agreement with Einstein's view. published in the year 2017. And I have had the privilege of reading one chapter in that book on atomic physics, which he has acknowledged that in the book. So with this short introduction to Professor N. Umakant, since because of his old age he is unable to come here, the advisory committee decided to do honors to him, felicitation at his residence later. Thank you.
Thank you, sir. Now I request Professor A.M. Khan, Honorable Vice Chancellor, to felicitate Professor K. Siddhappa, Professor B.G. Mulimani and Professor S. Umapati. Now, Honorable Vice Chancellor will be felicitating Professor K. Siddhappa. Now, Honorable Vice Chancellor will be felicitating Professor B.G. Mulimani.
Delegates of the conference and my very dear student friends. We are meeting here in this conference on the eve of the new year. First and foremost, therefore, I would like to offer my felicitations to you and greet you on this new year eve and wish you all a very happy, prosperous and peaceful new 2026. Well, it gives me immense pleasure to stand before you to participate in this important national conference on quantum physics and share some of my views on quantum physics, which probably all of you are aware of it. Well, before going to do that, I must recollect the contributions of the physics department for this important knowledge field in the nuclear science and technology, rather quantum science and technology, which the nuclear physics is actually a part of the quantum physics, by the Department of Physics, Karnatak University Dharwad. Besides being a field which has thrown very wonderful new lights on nuclear physics, quantum physics has also contributed immensely for very many applications, starting from lasers, electronic devices, up to the quantum computing technology. And I am really very happy to place before you my sincere appreciation to the department under the leadership of Professor M.I. Savadatti, a great visionary, who started the laser physics based spectroscopy studies in the Department of Physics, which is probably one of the first of its kind in the university system of the country. And he made a mark in this field by developing some new variety of lasers and also using facility to throw light, new light, and make original contributions to the field. Well, this was very well acknowledged in the international arena as well as in the country, particularly the DRDO, who therefore sponsored a major research project to facilitate doing some advanced work in the field of quantum physics. And I'm very happy that the successors of Professor Saudati, Professor Inamdar and others have taken forward to the research in this area and are able to continue to contribute some new interesting innovations, new knowledge in this field. In the light of this, organizing this NQCP 2026 in the year which is proclaimed as International Year of Quantum Science and Technology by the United Nations, very apt, relevant, and bear a special significance for the Karnataka University and the state of Karnataka. I appreciate all the sponsoring bodies, starting from this newly coming up and progressing Science Center to the Higher Education Council and other bodies. And with this introduction, let me say a few words about the quantum physics itself. Well, the development of this field, as all of you know perhaps, started in the year 1900 when Planck developed his quantum theory of radiation, in which he introduced the concept of quantum in the form of packet of energy, and he said light is containing this energy. But a real meaning for this concept was provided by, that is why the United Nations has declared 2025 as the century year of the birth of quantum physics. Well, as all of us are also aware of, this quantum physics mainly it started interpreting the interaction of particles with matter, quantum particles in particular, manner than what it was there till then existed. And in place of certainty of any event, uncertainty was introduced, and this Heisenberg's uncertainty principle is something which has played a major role and continue to play the major role in quantum physics. In place of certainty, probability concept came into being. And this is a revolutionary idea which we realize in the form of superposition of states. Superposition states probably exist, not certainly. And this superposition means it is the basic principle of waves. And this superposition of states is one of the main theme which taken quantum physics to greater heights and reached the present state, wherein we are in the era, in the threshold era of quantum computing. And in addition to the superposition of states, when quantum entanglement of these atomic and subatomic particles which was for quite some time only in theoretical, came into reality with the work of Schrödinger and his earlier workers, and for which a Nobel Prize was awarded in 2022. Although Albert Einstein has called long ago quantum entanglement as a spooky action at a distance, these experiments, subsequent experiments conducted over a decade or more period, have proved that it is a reality, quantum entanglement. And this quantum entanglement, as we know, is something unique which has taken forward the technology in a major way. The existence of this entanglement, which is responsible for the correlation between one particle and the other or others, is, along with superposition of states, provided a new powerful tool to understand the nature on the one hand and also go into very many practical applications. Even before this, and one of the first thing is transistors and other electronic devices, and then came the lasers, and lasers were responsible for establishing the reality nature of this quantum entanglement. And using these principles, how the newer and powerful approaches to the understanding of nature on the one and development of new technologies we have witnessed and witnessing further in future. With all these things, it has become possible now to say develop various technologies not only useful for industrial applications, even for the medical field and drug development of new drugs for the benefit of mankind. So all these definitely are very relevant contributions of quantum physics. Besides, it also is able to throw new light in the using quantum theory as well as the newly developed quantum mechanical theory, the standard model approach. And this facilitates actually to bring in these theories with the gravity, and the physicists in particular are able to combine these two as also the efforts are being focusing now on throwing new light on the universe in general. And at the same time, as far as technology is concerned, there are many challenges. Although these quantum computers which make use of the qubits in place of say, ordinary bits, which facilitates using the algorithms in a way that is going to be much faster than the earlier existing, now at present classical computers, and the stability of these qubits. That means even these quantum entanglement states is a difficult thing to achieve in order to develop more qubits computing systems because of whether it is small heat or small vibrations that are produced may cause instability. And these challenges, I'm sure, could be addressed by our future generation of researchers in this field. And for that, this conference is going to be extremely useful for the new researchers for the development of quantum physics. And I'm sure at least one or two aspects of this will be very clearly dealt with by the eminent and illustrious keynote speaker in the area of laser physics and associated laser Raman spectroscopy and all that. And the students and the younger researchers in this working in this field will be motivated further to continue their research in these areas on the one hand, and the presentation of papers, lectures of invited speakers, and the discussion followed will be able to find new ways to address these challenges and develop this technology also, take technology also forward with particularly in respect of quantum computing technology. With these few words, I again consider this as my very privilege and feel very happy that I am able to be with you, and I thank the organizers for providing me this opportunity to be with you. Thank you, one and all.
Thank you, sir. I now invite the guest of honor, Professor B.J. Mani, to address the gathering.
ಎಲ್ಲರಿಗೂ ನಮಸ್ಕಾರ. It's indeed an honor to be here. This two-day national conference, 100 years of quantum mechanics, is very, very important from the point of view of future of science, and hence future of all the students who are pursuing science and research, later technology and all that. Honorable Vice Chancellor, Professor A.M. Khan, very distinguished senior professor, Professor Sidappa, and a distinguished scientist at the national level who is providing suggestions for the development at various levels to the government of India. I'm very affectionate to our department. He has been in the department in various ways. That is Professor Umapati, my former colleagues, participants in the conference. Shiv Prasad is there, Prabhu is there, Kagli is there. They are all, they have come out of the love for the department. And this 100 years of quantum mechanics, my dear students, Professor Pureshwari, Professor Sidappa has outlined very briefly how important quantum mechanics is, all the way from Planck. This quantum mechanics is a very funny thing. It is a mysterious thing. Particularly students, you go and read what is Schrodinger's cat paradox, or what is EPR paradox, that is quantum entanglement and all that. It's just amazing. It's really a mystery. And it started with Planck, Then Schrodinger contributed, Schrodinger's equation, a differential equation, a wave equation kind of thing. Suddenly from the other end comes Heisenberg's matrix mechanics, different mathematical world, differential equations, matrix mechanics, and there comes Dirac, vector spaces. So different mathematical worlds. With the same physical reality. When I use the word reality, we don't know what reality is. That is the whole thing. Just, sometimes we ask the question, what is the case for physics? Case for physics, unimaginable questions. Can't you imagine the kind of questions we raise? What is reality? What is consciousness? All those things, they are embedded in it. Case for physics is unimaginable questions, wonderful rewards, continuing exploration of the nature. So if you just take a look, every generation of physicists have to rediscover quantum mechanics for themselves. That's what we are doing nowadays. So it's mysterious. And I don't know who said Bohr, important person. Bohr is also one of the important persons. And Einstein didn't believe that quantum mechanics is complete. It is partially true. Einstein believed in deterministic universe. But determinism is dead. Heisenberg's uncertainty principle. So these are the wonderful things. It's mysterious, and that's why they say every generation of physicists have to rediscover quantum mechanics for themselves. And it's another thing, one side we have mystery, mysticism, spirituality, everything about God, everything in this quantum mechanics. On the other side, technology is developing. We are talking about quantum technology, quantum computing, whatnot. And simple example, we started with nanoscience and technology. Plenty of room at the bottom. That is the thing. And from that point started, I'm not going into the details, do-it-yourself quantum mechanics. First chapter in quantum mechanics book is particle in a box. Quasi-continuous distribution of energy levels to discrete energy levels, whole thing started. Do-it-yourself quantum mechanics. Prasad will be talking about that wonderfully. So there is a plenty of room at the bottom, always do-it-yourself quantum mechanics, and whole thing started particularly in the semiconductor thing, band gap engineering. By band gap engineering, wonderful applications started coming. That's very, very, not only band gap engineering, energy, wave function engineering also started. That is another thing. So we have here two tools, band gaps and wave function engineering. So one can do many, many things which are unimaginable. That's why, I don't know, oversight or somebody, if you are not shocked by quantum mechanics, then you have not understood it, nor you will understand it. That's the whole thing. That kind of thing. Then that's the noise over. If you are not confused by quantum mechanics, you have not really understood it. The great guy, Richard Feynman said, these are not uttering just for the sake of uttering. For quantum mechanics, you really experience. Richard Feynman says, I think I can safely say that nobody understands quantum mechanics. He meant it very seriously. So, everything which we call as reality, is made of things that cannot be regarded as real. Everything we call real is made of things that cannot be regarded as real. So, these kinds of philosophical implications And I urge the students, read about that Schrodinger's cat. It will teach you a lot what quantum mechanics, what are the problems, deep questions, mystery and all those things. Same thing, EPR paradox. Every time Einstein used to raise an objection, give an example, Bohr used to raise one. If Bohr used to raise some objection for something, Einstein used to bring one more paradox. And when I said mysterious, consciousness, all those things come. What is truth? What is real? These questions we haven't really answered fully to everybody's satisfaction. Quantum mechanics is where they hide the scientific proof of spirituality. So, all the time, space, and all those things, this kind of things. But one thing is, miracles. When we are talking about laws of nature exist, and we human beings can divine them. That is what is happening. That's what we are meeting here. We have this quantum theory, quantum technology, quantum computing. So, in the end, I would like to conclude, but I urge students to read about this EPR paradox. That will give you an idea about quantum theory, quantum computers and all those things. When these greats, Heisenberg, Schrodinger, Einstein, Bohr, and then they are discussing, their philosophical aspects as I was doing. This side, quantum mechanics is going on its way. People are computing, people are doing, it is working. That is the thing. Then I will close it. One person, very well-known person, David Mermin, he said, you guys go on discussing the philosophical aspects, foundational aspects of philosophy. Shut up and start computing. Shut up and start computing. Let them discuss. Because when they compute, it works. It works as far as computers are concerned, it works as far as any explanation of results are concerned. So David Mermin said, shut up and compute that. So tremendous possibilities, wonderful theme on which we are really discussing, and students, Generation Z students, we have all the wonderful future. But quantum mechanics, where we are talking about lower dimensional semiconductor structures, 2D, 1D, 0D, whatnot, all those things. It's wonderful mystery. We have to prove it. Thank you.
Thank you, sir. The keynote address. May I now invite Professor S. Umapati to deliver the keynote lecture on laser spectroscopy and artificial intelligence towards medical diagnosis and prognosis.
Hello. 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 Okay. So let me thank the Department of Physics, of course, the Dharwad University, for the kind invitation. And it's my favorite place, I have to say, in Karnataka. I mean, apart from Bangalore, I love coming to Dharwad because of very good friends, starting from Mr. Saudati. I met him somewhere in Delhi and we started discussing and he said, you must come to Dharwad and spend time in the physics department. So that's how my relationship started in early 90. Early 92, I came for a workshop on lasers and so after that we've been coming. So it's a pleasure to be here again. And I've had few students from Dharwad work with me in the lab. And so this is all for it.
Okay, so coming to quantum, right? So so it's actually very true that
I think there's no contact. Maybe I'll. Oh, is it okay? Okay, all right. So, partly, what Dr. Mullimani was saying, Dr. Siddhapa was saying about, it's in a way about understanding quantum mechanics is if you're not confused, you're not understood, which I like. It's a good sentence because, it's like people believe in God, right? Then they ask the question, have you seen God? So why do you believe in God? Right? So the question is that the believers will tell you that I believe in God because I see the effect of God. Right? So same about quantum mechanics. Quantum mechanics once we see it by experiment, you will understand quantum mechanics better. Right? One of the things that we do in IISc, we are the third people in the world to do this, to use femtosecond laser pulses to get Raman scattering. Because the scattering theory tells you that the resolution of the signal that you measure is directly proportional to the resolution of the laser that you're using. Right? But Raman signals resolutions are extremely narrow. The peak is so narrow. Otherwise you can't see the various vibrations. But a femtosecond pulse has very broad line width, very broad spectrum. Therefore, if you put a femtosecond pulse onto a sample, the scattered line that comes off will also be very broad. You can't measure Raman spectrum. So Heisenberg's uncertainty principle tells you that is, if you push light to smaller and smaller and smaller size, the frequency gets bigger and bigger and bigger. Right? That's what you study. Frequency and time resolution, they are not linearly connected. So therefore, simple physicists will tell you that based on Heisenberg's uncertainty principle, you cannot measure Raman spectrum using femtosecond lasers. And in 2008, we published our first paper on showing you can measure, right? So when students come to work with me, I take them to the lab and show how we actually see action of laser light following Heisenberg's uncertainty principle, how cleverly we can beat the principle to get the signal that we want. And that's what makes it challenging. So today, experiments, yes, lasers are expensive, but still, that's what makes life exciting, doing experiments. So I'm going to talk about laser Raman spectroscopy. And I hopefully in the next half an hour, 40 minutes, I will tell you what we are doing in the institute. So I'm going to talk about, give you a brief introduction of Raman spectroscopy and biomedical research and the importance of artificial intelligence. And then I'll give you a couple of examples which we have already published in the system. Now, if you go to the doctor today, sit in front of him, doctor will say, what do you want? If you don't tell the doctor what your problem is, he can't predict what is wrong with you. Right? You have to say, I have headache, or I have high temperature, I'm not able to sleep, I'm vomiting, whatever. Then doctor will then measure few parameters and do some tests and then come and say, I think this is what is happening. Right? There are no markers which can 100% tell you in some diseases what it is. For example, if you get infection, now there is no way doctor can tell you by measuring your blood pressure or heart or wheezing or whatever, by stethoscope or even by MRI, X-ray, whether the infection you have is contagious or not. It's not possible. They have to do a culture test which takes 24 hours to 48 hours before they figure out it is infectious or not. Right? So that's a challenge today. How do we figure out? Is it possible that I can look at your body fluids, whether it is, for example, blood sample. Now blood sample contains red blood cells, white blood cells, blood serum, blood plasma, LDL, HDL, right? And then you have lipoproteins, and there are many components. Each one of them have contribution to a disease. Therefore, what we started in 2008, is it possible to identify a disease or a problem in a body by looking at the chemical composition in your body? Whether it is a tissue, whether it is muscles. So I worked with Drosophila samples to look at neuropathy. For example, we looked at neuron repair. You're looking at neurons and how they repair themselves. We look at how drug efficacy in a brain cancer. For example, this is called personalized medicine, right? So these are all papers I've already published. So if you go look at my Google Scholar, you will find all my papers related to that. One of the things we have done is with New Hands Hospital, we worked with the doctors, where we said we will take brain cancer. One of the problems today is, if you take cancer drugs, there are many cancer drugs are available. Some cancer drugs work well for some cancers, some person, but another person who has the same cancer, same drug will not work as well, so you have to give different drug. So they do something called hybrid drugs. That's all trial and error. Doctor doesn't know which drug will work for you, right? Because our metabolisms are different. So therefore, the cells that we are using, with the interaction with the drugs, hopefully the doctor will hope that it works. So what we did, we actually did that in the lab. So we tried to interact with 10 different drugs with 10 different cell lines of brain cancer, and then identified which drug is good for which cell line. So therefore, tomorrow if somebody has a brain cancer, we take the biopsy, convert that into cells, try 10 different drugs, and then tell the patient, this is the best drug for you. It's an expensive business, right? So because, you have to do it in the lab, set up everything and stuff. So personalized medicine is coming. It's going to come very soon, but it's expensive. So we wanted to see, is there a way that I can do quickly? Because we are looking at only chemicals, right? So that's why we wanted to use laser spectroscopy or Raman spectroscopy to read signals which come from chemical composition of these particles. So we wanted technology that I can tell you before symptoms. So for example, if you get an infection right now, in this room there are many people who probably have infection, including me. But if your immunity is very good, how do you keep your immunity good? Eat well, eat healthy, right? Have vitamin C every day, have a lemon juice every day, ginger every day. This is what, if you go back to our history of our families, 30, 40 years ago, I mean, it is amazing. If you have grandparents, you should sit with them and ask them what they had for breakfast, lunch and dinner. Right? It's amazing. So we had systems where people are eating food. right? Now everything is packets, we just open them and eat, and that's not healthy for sure. So if you're healthy, what body does is an attack comes in, an infection or a bacteria attacks you. Without you knowing it, your body develops antibodies and kills the bacteria. If you are very good immunity. If your immunity is not good, the bacterial generation, antibody generation will be less. Therefore, it keeps fighting and fighting. When the fighting starts worse, the number of antibodies increase. When the number of antibodies increase, you start getting fever, headache, and pain. Then you go to the doctor, then they give you medicine to bring it down, right? So we know that the chemical composition work starts as soon as the infection attacks. What we can do is, by looking at the blood sample, I can tell you that your infection has started in your body. So can we identify a disease before the symptoms appear, before you start feeling pain, before you start having high temperature, can we actually identify? Now, infection is the simplest example I told you. Much worse is heart attack, diabetes, right? Can we actually see how close you are to the heart attack? So therefore, they can start treating you before. And one example, right now we have a technology through my company, is to look at sepsis, organ failure. We can actually look at a plasma sample from the patient as soon as, for example, if you go to a doctor and say, I have a serious kidney problem or a lung problem, the doctor suspects that you have serious issue, they will send you to a super specialty hospital, a tertiary hospital. You go to an ICU. The first thing ICU guys do is take the blood sample and send it off to check whether you have sepsis or not. The problem with sepsis is that it's an organ failure disease. So your organ starts failing because you have excess infection. Now the blood test will take 24 hours, 36 or 48 hours before the sample come back to the doctor. So doctor doesn't know whether you have sepsis or not. Then they have to decide what spectrum antibiotic to give. If you don't have sepsis, if they give antibiotic, it's not good for you. So 50% of deaths today, all over the world, not India, all over the world, is because of sepsis in ICU. So this is a problem we started about 2012 with animal model. We started with mice model, we went to rabbit, and then we went to human model. Right? Today we have a machine which can tell you within 10 minutes whether this person has sepsis or not. Again, this is purely from plasma samples of the patient. When they arrive at the ICU, they take blood sample, immediately put it in our machine and look at the report. The report will tell you whether you definitely have sepsis or probably have sepsis or no sepsis. Because the probability is medical association. So there are some rules which I don't discuss. Decide what they want. So that's what. So we actually look at others as well. We can look at body sweat. You can look at tears. You can tears, for example. You'll be really surprised. One of my friends in the US is Tony. He can differentiate between a happy tear and a sad tear. Right? I mean, look at the chemistry that is going on in your body. So they can actually identify now the blood sample is from a male or female or an animal, or is the blood is from an young adult or an elderly adult, using normal spectroscopy, right? There's one of my friends in US working with the forensic department and the Homeland Security, trying to, for crime scenes and various other things. So, we are looking at different things. So I'm using Raman, right? So you probably know that if you put light in, you get lights out, so you can measure the various frequencies that come out. And unfortunately, Raman scattering is extremely weak. So that is why it is not so popular, because unless you understand optics and lasers and spectrometers, it's not easy to measure the spectrum. Because the spectrum you get is normally very noisy, and if you don't know how to do mathematical processing, it gets much more complicated. So that's the reason why people don't normally do it, but it's getting better and better, and so you will probably get a better spectrometer in time. But we build our own spectrometers. So what happens is that if you look at biomedical systems, if you're looking at a bulk bacteria or a single bacteria, or look at biofluids or tissues, we can learn a lot. And these are the kind of signals that you get in Raman spectrum. So by analyzing these data, you can actually try to identify disease diagnosis. And that's what we try to do. Now, unfortunately, medical is very complex, right? Now, if you're for example, South Indians versus North Indian, right? Or somebody from Kerala, from deep Tamil Nadu, metabolism is very different, right? So if you look at the composition, metabolites in your body is very different. Genomic differences between people to people, European. In the olden days, I'm going to show you an example. In the olden days, FDA, the American Drug Authority, asked you to do a trial and show the data. In about 15, 20 years ago, as long as there is 100% patients were tested, they will approve the. Now they have gone to a different kind of trial. Now what they are asking, you must have 40% white Caucasians, 20% blacks, 20% Indians or South Asian origin, and 20% of Chinese, Japanese origin. Because they figure out that
Making a drug for
one particular genomics group is not working for other group. So this is something is making life complex for us, because if the sample itself is diverse, you can't have a universal diagnosis kit which is going to work for all cultures. So you need to develop different ways. So we need to understand. So that complexity work comes in. Now, when you record Raman spectra, I'm just going to go. So if you take a simple cell, the kind of components you have DNA, lipids, proteins, RNA, and many other components are there, polysaccharides. So each one will give you a signal, Raman signal. Unless you understand where the signals come from, you can't analyze the data. So what we do is we try to look at each of these very carefully, each of these frequencies. And this has been going on for the last 30, 40 years. 1970s, people started looking at biological systems. So there's enormous amount of information as to what this frequency means, what this amplitude means. So we can try to understand them from simple physics and mathematics. For example, if you look at protein structure, you can have alpha sheet, alpha helix and beta sheet. They have unique frequencies where we can actually, looking at those frequencies and the bandwidth, we can tell you what is the relative ratio changes that happens in a protein. When alpha helix goes to beta sheet, you know that it is unfolding and denaturation happens. And that's what we look at. So, if you look at 2 or 3 samples of bacteria, for example, E. coli and aureus and all that, you can easily separate them out in simple way. But if you go to something much complex, for example, you will see that it gets very difficult to separate out see, this we can separate, but if you have multiple classes, the overlap is good. The store so close that you can't identify which bacteria you're looking at. So this is called the machine learning process. This is a clustering, hierarchical clustering methodology, where if the difference is large, you can separate them, but the difference is minor, you can't separate them. This is where AI comes in, because AI is something that can help you to differentiate these samples. So, I want you to know a little bit about the AI. The problem with the AI is there's a lot of confusion about what is AI. Right? If a simple logic, writing a program, can identify a solution, and if you can think that this is the solution, that's not AI. That is logic, right? That's pattern recognition. So if I give a pattern, teach the computer how to recognize a pattern, that is machine learning. That is not artificial intelligence. Artificial intelligence is when you have set of data that you cannot see the variables, you cannot separate them out yourself by all the mathematical method that is available today. You tell the computer, can you identify differences between these sample data sets and tell me what is it? So basically, the system, the computer system that separates out the data and comes and tells you, I'm seeing differences of these kinds in the data. And then you train them, no, this data is useless, but do it this way. So we train the computer to learn the data and then try to tell you what you want to learn. And that's what AI is all about. And I just want to talk to the students. So how many of you are using ChatGPT or some other AI tools? Good. So I'm going to tell you something, right? ChatGPT, unless you pay for it, you will not get the right tool. So if you want to learn, if you don't want to pay but still want to get a good result, right? You have to go to a program called no, but Echo will come. Both. Okay. There is a program called Perplexity. Do you know that? So download, use that, right? Or Gemini. So Gemini and Perplexity will give you references at the end of each result. Click on the reference, you know where the information is coming from. And that information has to be true. In artificial intelligence, particularly in the large language models, there is something called hallucinations, right? You need to see the dangers of hallucination. What happens is that the computer system starts imagining things by connecting two things which are not to be connected. And then gives you a result which is wrong, right? And you learn that, you'll only learn wrong things. So there is dangers of, for example, lots of videos generated by in YouTube, generated by AI methods, so that people can make money, right? A lot of people are doing it all over the world. AI is being used to create more money by creating videos which are wrong. And more people watch it, more money they get. Right? So if you go and watch any YouTube, the guy who speaks will always tell you, please click on the subscribe button. Why does he say that? Because if for every 1 lakh, they get some $100 or something. Right? So they want to make more and more money. That's why people go to YouTube. So you have to be very, very careful. The second thing that you need to be careful about AI, I'm sure if you're playing computer games on your mobile phone, you will be getting advertisements. Right? All of you have seen that, no? And that's dangerous. If you do an AI, use an artificial intelligent program to hurt someone or to say something bad about someone, I can tell you, when the person comes to know, if they complain to the police, they will immediately file a criminal report. Once a criminal report is filed against you, you will never get a passport in your life. This is the danger of AI, right? People don't understand. There are computer programs where you can do a lot of bad things. You can put somebody's photograph and make them look like actually they're somewhere which, some other place. And that's not good, because if you do that, if that person comes to know, if they go to a crime cell and say, somebody has done this to me, I can tell you. I'm not sure how much you know where AI is going. I have a Meta AI sunglasses. Okay? I can look at Jagdish and click on my sunglasses and say, who is this person standing in front of me? I will hear in my ear, because the glasses has a speaker. This is Jagdish Tonanava from Dharwad University. My glasses will tell me, right? So all of you are connected all over the world. So you have to be I can track you down to the time and the location where you stood and checked your mobile phone. That is the status today. In China, for example, in Dubai, airports, you don't have to go through immigration. You enter. As soon as you come out of the aircraft, your face is captured, goes into the computer center. And there are officers standing there. They get information. This guy with the blue shirt has not been immigration cleared. Catch him. Because system takes care of everything. That is the level of AI is going. So you can use the AI to learn. For example, quantum mechanics. What is quantum entanglement? What is the application of entanglement into real life application? So you can go to Perplexity and ask the question. You can even add the question saying, I am a 10th standard study student. I don't know anything about quantum mechanics, but I would like to learn about what is entanglement or quantum entanglement and what is the use in the future. It will tell you like a 10th standard student, the AI part will tell you. So use Perplexity to learn things which are important. Particularly for students, I always tell you, at least you should spend half an hour every day on YouTube looking for AI applications in physics. If you want to be employable in 5 years from now, that's what you have to be. If you don't know AI, if you don't know quantum, I can tell you job will be very difficult because the AI is now taking over all the simple jobs. So the next level of job is going to be people who are knowledgeable about AI and how you can use them. And therefore you have to learn them. So that's important. So now we have been using AI for the last 15 years. 2012, 2014 we started. Now we are actually doing it commercially. So what is neural network, right? Some of you might have studied, so I just want to tell you how simple it is. It looks complicated, but it's not. Right? So if you take a neuron in our body, so there are dendrites, right? There are axon terminals. So what you're doing is, the dendrites actually fill the thing. For example, somebody touches you in the back. How do you know somebody is touching in the back? That's what neurons do, because neurons recognize that there is some change in the pressure or wind or something like that, and feeds that information into the nucleus, and then goes and sends here. The axon terminals act either in your ears, nose, perception of what's happening. So if the smell is changing, they are sending signals, and that's how you recognize them. That's how you recognize color, you recognize shape, because they are all because of neurons, right? So you have various variable information that is given here, which goes through and gives it to sensors in the body, right? If you, for example, some heat, that you feel the heat, you immediately take your hand off. That's a sensor that is given by this axon terminal, the sensor reaction. What is your response for stimuli? And so similarly, so what we can do, so they came up with this idea that you can actually put variables inside and try to get an output. So I'll try to give you different heats and see what temperature is required at which you remove your hand. Right? Similarly, you can keep on doing this. So this is how we do in the artificial neural network system, where you actually feed information with variable weights and then see which is important and then come out. So this is basically a simple concept of how AI works. And the olden days, in the late 2000, mid 2000 and late 2000, we used to use artificial neural network, right? It was used mostly for statistical analysis. But then they came up with this CNN, convoluted neural network, which actually made a big difference in trying to predict even simple things which are very simple variables or low intensity variables which cannot be separated out in ANN. ANN was failing in many places, so CNN became much better, which is then became artificial intelligence. And that's what we do. So there are advantages and there are disadvantages. You need to understand. One of the biggest disadvantages that people found was something interesting in IBM. The very first face recognition tool of a camera, if somebody walks by, it tells you who is the person walking by, right? So what is interesting was that the guy who programmed was a white American computer scientist. He took 100 white American computer scientists and put it up on the computer system, and so any white American comes, the camera will say there is a man walking. When a female walks, it doesn't recognize. When non-American, that is black Americans or Spanish American walk, it doesn't recognize. Now that is called the bias of training, right? So then they realize that's a big mistake. We have to make sure that we train the AI properly. That means you must put every possible variable for the AI to understand. When you say a cat can be, brown, white, black, all colors, right? So you'll train them to say these combinations can happen. Similarly with humans, can be tall, small, shorter, longer, healthier, bigger, smaller. So that training requires intelligence. That is human intelligence, perception of the problem. So the feeding of information can actually lead to bias and which can lead to wrong result. And that's very important. The other problem is that, when do you stop the machine from learning? This is what happened in, for example, San Francisco. AI was controlling electricity in the city, and they taught the system to say, you monitor how the electricity is distributed every day, right? Daytime, lot of load, nighttime load is very less, and rich areas, industrial areas, nighttime load is high. So this kind of learning every day. So they let the computer to learn. At some point, it so happened during a festival, late night, normal citizens had light on. So suddenly the computer felt that there is something is wrong. So it shut down the whole electricity. So the whole went into a loop that you can't understand compared to last 300 days. Suddenly one day something is wrong, right? Computer could not take it, so it shut down everything. And then they had to go back and reset the whole thing. So this is the dangers of AI, which means if you don't train the AI either overfit or underfit, it can actually give you wrong results. So even training an AI requires reasonable knowledge of how you do this. And of course I said, this is something is becoming a problem. For example, I told you about the legal issue, where if you do something wrong, you can be arrested. You can't say, I didn't know, right? It's like stealing something, right? You see that there is 1,000 rupees kept on the table, and nobody is there on the roadside. You can't take it and say, oh, it was there, I took it. That's not an excuse. If it is valuable, you have to go and give it to a police station or somewhere, give a report saying, I found something. So innocence is not, you can't use it against being guilt. Right? So this is the problem that the AI is bringing. Now, US and America is going through a serious problem. For example, an automatic car, a robot-controlled car, in the US, one of the issues now come up is get into an accident. Now the robotic car is used as a taxi. It is actually happening right now in Los Angeles. You can actually hire a car in robotic car. It'll come, it'll open the door for you. You sit down and press a button, it just goes. Now if that car, you're a passenger, get into an accident, who is responsible? Is the person sitting inside the car? Or the company which allowed you the car to run? Is the guy who wrote the program in robotics? Or the mechanical failure that happened because of the mechanic? So they don't know how to define the rules. So now Government of India as well is making a committee to look at the legal implications of AI. Where do you stop? At what point who's responsible? So that you can take action on them. And this is a very complicated area. So one has to have transparency and reliability. And the trust will only come by demonstration. Now, for example, many a time, you don't know why you got that result. And that's one of the bigger problems with computer scientists. You ask them, how did you do this? We don't know, because the mathematical model inside is too complex. So it's like a black box. Even the computer scientists don't understand beyond a certain point. Why you managed to get the good result is difficult to understand. So now what has happened is, a lot of people said, no, how do I trust this, right? So, you don't know how you got the result, but tomorrow if you don't get the result, what will happen? Can you trust? For example, can you fly an aeroplane thinking that I don't know how you got the result, but I can ask the AI to run the aeroplane. So now they're asking, the new technology which is coming up is called explainable AI, which means you can explain why you got that result, right? You can't leave it to statistics. So it's evolving so fast. That's why I'm saying ChatGPT came in 2022. Now ChatGPT 5 has come. Now when ChatGPT came out, only other challenger was Gemini. Now you have 7 or 8 chatbots, Russians, Chinese. And one more thing I want to tell all of you. Anything you put in a chat GPT or any artificial intelligence, public domain software, any information, including your research results, it goes into public. Once if it goes public, you are lost legally. You have no control on your data. For example, I tell my students, no result from our lab should ever be in any public domain software. Because what ChatGPT does, it searches the internet from the feed that you are giving. All of you feed information. Whenever you ask a question, that is information you are feeding. That gets stored in the system. Now, if I do a plagiarism check of your thesis, which you wrote, which some students have done it, right? They write an essay and give it to ChatGPT and say, can you rewrite it better for me? It will rewrite it better for you. But the problem is that is already gone into the database. Now, when you submit the paper, let's say, for example, a thesis to university, if Dharwad University checks on a plagiarism check, whether this thesis is actually original or a plagiarized, it will show plagiarized. Because you have already preloaded the data. So you have to be very careful when you're actually trying to use AI. Okay, so now let me go to our results. So this is what we do. So I'm just showing you how we do all these things. So I'm going to show you an example of what we did in IISc. These are all published. So what we did was, there's one of the things that happens in hospital is what's called hospital-acquired infection. Right? So normally if you have a heart operation or a transplant of body parts, liver, kidney, whatever, the doctors normally give you immunity suppressing drugs because they make you slightly immune, because you should not pick up, because of disagreement with the new organ, you should not get it in your disease. So they reduce the immunity and then they feed this. Now what happens when your immunity is less, you just had an operation, 99% of the hospitals, 99.9% of the hospitals, because particularly in India anyway, we don't follow rules, right? ICU, all of us walk in, walk out. If your uncle is there, your aunt is there, say, no, come on, it's my mother, I come to see. And you fight with the nurse, you get in. Every one of you are carrying bacteria in your body, in your clothes. Now, if that bacteria goes into the hospital, a weak patient who is immune suppressed is there with an operation. They pick up this bacteria and get into infection. And that is called hospital-acquired infection. So while they are recuperating, if this infection comes, they get into complication, heart attack and other issues come, right? So the idea is, can we identify these pathogens inside the hospital, in the environment? So typically, the hospital-acquired bacteria are normally called escape pathogens, right? ESKPE, escape. So this is very well known in the biomedical circles. These are the different kinds of bacteria that they do. They actually look at, you can take this from urine sample, blood sample, or wound sample. You can take a swab and then look for bacteria. And the question came to us saying, look, this is going to take me 2 days to find out what bacteria it is, because they have to do culture and then find out from the culture what bacteria it is. So, can we do it instantaneously, is the question. So we decided to look at that. So, anyway, it's all comparative methods. So the idea is that we take the bacteria, we grow them a little bit, and then separate the bacteria and record the spectrum of all of them, right? You see what you get. All look very similar when you look at them. Then we actually go into normal statistics. It doesn't work, your machine learning tools. And so therefore we go into AI. And this is what we do in the AI model. And we actually get accuracy as much as 98.66%. We can tell you exactly what bacteria within 10 minutes. That's the advantage of using technologies like this. And then I'll show you another example of this is to identify pathogens in general. One of the things that happened was I gave a lecture like this in during the COVID period. AIMS Bhopal director, Dr. Sarman Singh, was in the audience, and he said, look, we have a problem, we need some help. The problem was that AIMS is a very well-known hospital, right? So a lot of people go there. And during COVID period, this in October, November, December, because of the weather, people also had flu. Now, when the patient arrives at the hospital, the biggest problem is everybody's, as soon as they come with the infection, infection with the nose and pain and, breathing issues, every nurse, every doctor think that it's COVID. Then they give them the PPE kits, masks, and, isolate them. And he was saying we are wasting so much of resources and anxiety, somebody who may have a flu need not to do all this. So he told me, can we find a way to separate it out, whether it is flu or it is COVID or any other. So I said, okay, let's start. So we did a project funded by ICMR, and this is the result. So, people can come with COVID and flu, and then we also added dengue at the thing. The symptoms are very, very similar. You will see cough and difficulty. So people use RT-PCR, and of course, or you can do antibody test. And so what we did, we actually got samples from this is interesting, right? So I want to tell Vice Chancellor is here, she should know, right? In IISc, when we started this project, so all these projects require ethical clearance, right? There is a committee, ethical clearance committee, which actually goes through this. And IISc ethical clearance committee said, because it's COVID and flu, they said you can't do it, it's not allowed. And I said, how do we do this? Then they said, blood samples. I talked to Salman. Salman said, how can you do this? Come on, we do this every day. How can IISc say this? So he wrote a letter to the director of IISc saying, look, we are giving blood samples. And in the blood sample, there is nothing to infect, right? Even if you touch it, nothing will happen. So whether you unnecessarily, it's only breathing that thing that actually leads to infection. And even then, some of the members in the committee said, no, we cannot. So the solution was that AIIMS Bhopal has to do a sensitivity test to see every sample. They have to make sure that it is not contagious by running RT-PCR and other tests, and then send it to us. Right? So this is the kind of bureaucratic complications which is unnecessarily comes in. And in WHO it clearly says body fluids, once if it is taken, is not contagious. Which is, but anyway, it requires knowledge. So anyway, we did. So they sent us the sample. We actually looked at spectra of a large number of samples, and then we trained them. So you can see that typically you have fever, cough, cold, headache. And there are two things, which is, a lower respiratory and upper respiratory infection. Different people will have either lungs or even lower thing. So we need to figure out what it is. So we try to do all that. And you can have high fever. For example, if you have dengue, you could have high fever, joint pain, dizziness, which is not the case here. So there are indications that you can figure out. So, but then you don't know a priori when the patient arrives. So we want to do it quickly. So we did that. So this is our normal. We always do a machine learning first. See, we get 55% accuracy, and then we actually AI. This is called generative adversarial network. This is a recent, last 2-3 years, AI model which has come for a very complex database, and we use that. And so what we did was, we did a binary. So we take a sample of the patient, first separate whether you have disease or not, because sometimes, people will have just simple viral something, so you don't have to worry about. And then we take the disease and then separate them into flu, COVID versus dengue, and then flu, COVID can be separated. This is what the computer does. So you can see now, we can actually predict flu at 93%, COVID and dengue at 100% accuracy with respect to healthy controls. And that is where we are today. So the next technology which is going to come into the market is a small machine which can be deployed every primary health center whenever if there is, for example, an outbreak of viruses. And so what we do, we take 3 microliters of plasma now, because we don't need much. We need only 1 ml of blood, which we can spin and take a plasma. And then within 5 minutes, we can actually tell you what the result is. So we can say that it is flu or COVID or dengue or a healthy patient. So anyway, I'll stop here because, so, funds are given by DST and DBT. This is my old group and this is my recent group in IISc. And of course, I've collaborated with a large number of people. Kumar Somasundaram is an expert on brain cancer. And Dipankar Nandi is a biochemist who works on immunologist. Anuragarajan works on stem cells, and Sigdar is on neurons. Naktomba works on model systems, Drosophila. For example, lifetime-based diseases like muscle-related disorders cannot be studied with humans. And you can study them because 70 to 80% of genomes of this fruit fly is the same as humans. So all the hospitals and medical research guys use that if you want to study. And Deepak is a bacteria expert. Vani Santosh is a pathologist. Geeta Mukherjee is an oncology expert. And of course, Kulkarni is a good friend of mine who is a public general practitioner. He's somebody who is brilliant, general practitioner, very famous guy. And of course, funding comes from not only from DBT, DST, from industry, Boeing, Hindustan Lever, ITC, Unilever, Procter & Gamble. Because when you're running a lab, you need funds for lots of things, and so we get them. And thank you for your attention. And if you want, my paper, some of them with AA is here, so you can read. And for example, the first paper, this is, for example, has the largest citations, because we have actually demonstrated, mathematically explained how to analyze data of Raman. So data processing. Okay, so any questions? I hope it wasn't too long. Was it okay? No.
Sir, you said something about personalized cancer medicines. So is it because of a mutation or what?
No, it's not because of mutations. Because the genomic differences in metabolites in your body and the proteins, the relative concentration of protein changes, for person to person it is different. And even today, I keep arguing with a lot of Indian doctors, right? So, medicines discovered in the West, so welcome. Never use Indian clinical trials before India approves the medicine. Once they approve it there, we just adapt them. So, that's something we need to do. It has to be done, but I think they'll start doing it soon. Mutations can happen over a period. This is something very controversial topic.
Mutation of cancer cells.
Yeah. So this is something is happening all over the world. This is hereditary diseases, right? It is example of now people are trying to do something called genomic tests to see, will your children will have a problem, the problem, so if you're diabetic, can you say your children will definitely become diabetic or not, right? So there are companies now, if you pay 25,000 rupees, 30,000 rupees, they actually look at your genome and say which genomes are missing and therefore what diseases you're likely to get. And therefore you advise the children that this is going to happen to you, which is controversial because of mutations. When they are born, they may have certain set of genomics. As you grow, these can change. And that can actually stop you from getting diseases. So people don't understand. So if you go on YouTube and find out about genomic, hereditary genomes, there are guys who will talk about it's not true because of mutations. Yes.
Continuing on what he said, like even in the COVID, right? We're seeing a lot of mutations which are happening.
Correct.
So do they give exceptionally different Raman spectra at that
Yes. So this is very interesting, right? So when I was looking for investment for my company, right, the investor asked me, okay, if you sell the machine, what happens after that? How do you make money every year? So I told him, don't worry, mutations are there. Right? So one of the things what we do is our database, the AI model we developed, we expect hospital to subscribe. So 5 lakhs a year. So what we do is every time these mutations happen, because we in the back end, we monitor our accuracy with continuously working with hospitals. But the accuracy drops because of mutations. We retrain the AI and go and upload the model in all the hospitals. So that guarantee we give so that, you pay for the subscription.
I think that's what Dr. Kamble was mentioning. But that also needs personalized diagnosis.
Yes.
That's the point.
No. So,
Yeah.
no. So,
Okay, anyway.
Yeah.
Another small question, and because of the signal being very small in Raman, now people are using surface enhanced Raman spectroscopy,
Right.
using plasmonic coupling.
right.
So have you also tried that, or
We
how
have.
do you find that useful?
Yeah, we have a few papers on that. See,
But how is it? I mean,
that's like quantum mechanics.
yeah.
Okay, I'll tell you why, right? So, when you say plasmonic coupling, you already determine the surface charge, right? Surface charge of the particle and the other charge of the material that you're trying to interact. Now, unfortunately, if you look at the zeta potential of nanoparticles, you can either make them extremely positive or negative or neutral. Now, unfortunately, in material that you're searching, if I make one nanoparticle for a particular material, you'll have to make another nanoparticle for some other material. So there is no way a nanoparticle can become universal. So this is something that people are trying to. It's good for publishing papers because students will get 5-6 papers. But realistically, when you're applying to real life, I doubt you can get it.
Right now, but probably the signal enhances so much.
Yeah, but what I'm trying to say is
Yeah.
the fact that the interaction between the material and the plasmonic
Yeah.
has to be strong enough,
Yes.
and the materials must have same surface property to give the same signal.
Yes.
Unfortunately, if you take amino acids or if you take any material, whether it is explosives, narcotics, not all of them have positive potentials. If you look at the surface charge,
That's
right? So therefore, when you bind, which are not binding strongly on the plasmonic material, which is negative, you will not get signals. And that's happening right now.
But you could do some interface manipulation for you.
They have been trying all that.
Yeah, exactly. So
You've seen that, right?
It'll happen, yeah, it'll happen basically. So,
I'm not sure,
Yeah.
because see, nucleation growth is an area which we don't really understand. Right? Crystallization, for example. Nobody understands what drives crystallization. If you know polymorphic forms of different crystals, right? Nobody knows where does it initiate, whether it is cubic or tromboidal, right? So, we have a lot to learn before we can. Yeah.
thank you.
Yeah.
Curious, if blood is not a contagious to the virus, but you're drawing the plasma through the and I'm just
So, so what I'm saying is, the chemical compositional change in your blood reflects the disease extension in your body. That's all. So if I take, what we have done is we have taken red blood cells, white blood cells, plasma, serum, all of that. I mean, in the animal models. We arrived at a result saying the largest change in the chemical composition happens only in plasma because of infection. So we then take the plasma and look at the changes in chemical composition.
So these virus, even under mutations, they show specific signals.
Yes. There are, so it's much more complicated. So there are companies which are selling spectral data, right? Now, if you know the Raman cross-section or polarizability of the bond, that polarity of the bond and the efficiency of scattering depends on the wavelength of light you're using. If I use, for example, 400 nanometer light, the intensity of signal that I see is much larger. If I use 700 nanometer light, intensity of that signal is much bigger. Therefore, you can only say the frequencies can be the same, but amplitude may not be the same. So although there is a database, the database frequency can be used, but amplitude cannot be used.
But amplitude matters to you.
Exactly, that's the point I'm trying to make. So there are databases, but it cannot be used directly for your application. You have to develop your own.
So if there are no questions, let us thank Professor Mahapati for his brilliant talk.
May I request all the dignitaries to occupy the seats on the dais. May I now request the President of the function, Professor A.M. Khan, presidential remarks.
Good afternoon to all of you. Respected chief guest of this two-day national conference on 100 years of quantum physics developments and multidisciplinary applications in novel materials, NCQP 2026. Former Vice Chancellor of Bangalore University, my teacher and mentor, Professor K. Siddhappa. Guest of honor of this program, my teacher and well-wisher, former Vice Chancellor of Gulbarga University, Professor B.J. Mulimani. The person who opened up our ears and eyes through his talk now, Honorary Professor of IASC, Professor S. Umapati, the Chairperson of Department of Physics, Professor Jayashree Tonanawar, Convener of this conference, Professor Bhajantri, distinguished teachers of Department of Physics, I can name all of them. They are all sitting here like shining stars. My colleagues from Department of Chemistry, Karnataka Science College, other distinguished invitees, invited speakers, Professor Kagli, Professor Shiv Prasad, Professor Jari from Gulbarga, distinguished speakers, student friends, ladies and gentlemen. You have now heard three speakers speaking at three different tones. Probably, to begin on a lighter note, I will recall Richard Feynman, the acclaimed physicist, who said, if you think you understand quantum mechanics, you don't understand quantum mechanics. After having heard three speakers, and especially Professor Umapati now, linking AI to Raman spectroscopy, to the topic of what we have been, I think we have not understood anything. It's to tell you on a lighter note, but it also tells us there is a lot of scope for all young students here to learn, to explore what is all this about. Applications of AI in biomedical, especially directly into medicine, the experience shared by Professor Shiv Prasad now, and what is it all going to happen, what all is going to happen, how they have developed samples and all was quite interesting, and all of you have heard that. Quantum mechanics is having a big impact. Discoveries that were made centuries ago are being talked of now, and still we are not understanding anything of that. By the statement, entanglement itself, a particle though at a distance being, say, attached to us, we are all into that entanglement now. We have speakers coming from Bangalore, we have distinguished guests who are all from different parts, students in the Department of Physics, from different departments, all are entangled to understand what is quantum mechanics today. A very nice, say, concept, and we have been discussing that part of it.
Today, whatever we are discussing, mostly into, say, the applications of that have gone into quantum computing, solar cells, light emitting diodes, GPS, everything is all possible because of quantum mechanics. See, quantum computing is one of the important areas where a lot of computing is taking place, and that has opened up era. And I think Professor Umapati now explained to us how AI is using quantum computing and what are the applications of AI. What is required more now is to develop more materials to make it more specific. And probably this conference is concentrating on novel materials for such applications. Samples are being used. Now, for a moment, when Umapati was telling, I was feeling going into an ICU itself is dangerous. And I also had a feeling, maybe I may be wrong, but I also had a feeling, many of the people who died during COVID, maybe because of that contagious things that happened in the ICU itself, maybe all were classified as, say, COVID, but they might have been just because of flu. Some might have felt suffocated in that kit itself. We don't know what happened inside an ICU. I think that opens up the eyes. That's why I told you, his talk opened up our eyes, and we are made to think in different angles as far as the applications are concerned. So all students and researchers who are going to have deliberations over the next 2 days, think of materials which can help specifically for a good humane society and how we can take it forward. Quantum computing is still a wide open area. By the end of 2027, 10 lakh jobs are expected to happen in the market of quantum computing if we are really using it in that particular purpose. In high energy physics, lot of quantum technology applications are going to come up, and that also is going to give us, say, therefore we require highly sensitive or say very effective sensors, and that is where material science has to connect to us and bring about changes into that particular area. So therefore, quantum states, qubits, then quantum protocols, quantum algorithms, quantum hardware, superconducting materials, so many things are still to be explored, and I think all researchers will take it in a positive way, and our student community will benefit out of it into all of these say impactful research. And this, I hope this conference will take or open up rather than take you forward into thinking more on the applications of quantum physics, how it can be used to build a more application oriented say field of research, and then how it can be used for some good human applications, especially after having heard this into medicine first, so that we all live happily, and then into other fields of speed or driverless car or whatever it is. So I wish all this particular conference, I hope all of you will have a quite fruitful interaction. My appeal to the students is don't hesitate to ask questions. Professor Shiv Prasad or Professor Kamble asking question was different. But when such a good speaker was there, students should have come up with questions. Young minds should understand. Now you already know that nothing can be understood, isn't it? Professor Molimani told us that you have not understood anything. So Richard Feynman's statement, so don't hesitate. It may be a serious thing for you today, but that opens up a big say field for you in future. It may open up a research idea for you for which you can do your PhD. Therefore, my appeal to the students is, when speakers are speaking here, listen to them carefully, and whatever you feel like, ask them openly. Have the habit of asking openly. That may open up so many good discussions, and the department can come up with so many new ideas for research. So I thank you for the opportunity. I thank Professor Umapati for his insightful talk, and our teachers, Professor Siddhappa, Professor Molimani, for having graced the occasion and then say opened up our eyes and shown us field. Especially for me, because my research area is into biomedical electronics. This particular talk on AI was much, say, which incited many more ideas of what we can do in future. So I hope all of you will have such exciting ideas that come up, and this conference will be more successful in opening up the minds of the young students here into, say, leading, say, to contribute nothing but to the subject. So I thank you for the opportunity. Thank you one and all.
Thank you, sir. To formally conclude this inaugural session, may I invite Dr. Sukanya Patil to propose the vote of thanks.
Good afternoon to one and all present here. As the organizing secretary of the conference, it's my pleasant duty to express gratitude and acknowledge encouragement and support received from different people and organizations on behalf of the advisory and organizing committee of the conference. Firstly, we are grateful to the chief guest of today's function, Professor K. Siddhappa, for inaugurating the conference and addressing the delegates. He kindly accepted our invitation despite personal constraints. Therefore, we appreciate his generosity in giving valuable time for the event. We are very happy to express a depth of gratitude to P.G. Mulimani for being our guest of honor and also constant support and advice during the preparation for the conference. I also thank Dr. Shankarappa Mani for his academic support in organizing this function. We are extremely grateful to Professor Shiva Umapati for kindly accepting our invitation to deliver the keynote address. His topic of the address must have excited the delegates and participants too. We are also very much grateful to Honorable Vice Chancellor Professor A.M. Khan for his support, advice and encouragement during the preparation and also presiding over the function. Thank you, sir. We sincerely thank Professor Srimati J.J. Tonannavar, the chairperson of the department, for her constant monitoring of the subcommittees for the smooth execution of the work. And also Professor R.F. Bajantri, convener of the conference, for supervising all the committees, arranging for the necessary material as administrative support. Our conference has been organized under the soft component of Pradhan Mantri Uchatar Shiksha Abhiyan and Karnataka State Higher Education Council Bengaluru, for which we are grateful. We also gratefully acknowledge the material grant from Dr. M.R. Gorbal Foundation and financial support from Karnatak University Alumni Association and SPE Student Chapter. We also thank all the resource persons who accepted our invitation and for being here to deliver insightful talks. I thank all the dignitaries for releasing the abstract book of the conference. We also thank Dr. A.S. Bennar, co-convener of the conference, all dignitaries, faculty members, retired professors, all committee members, research scholars, student volunteers and participants for their involvement at every stage of the preparation. I also thank all media peoples for the coverage of the function. Once again, thank you all for your gracious presence and support, and we look forward to your fruitful deliberation for the next 2 days. Thank you. Thank you all.
Thank you, madam. We now